Okay, welcome to example number 5. We're going to find the kinetic energy in a reaction where polonium decays by alpha decay and produces lead with this atomic mass. So the first part, we want to write the equation for this alpha decay reaction. We have polonium 218 that decays to the daughter of lead, and that it would be 214 rounded. And we need to know the atomic number of that, and that would be 82, because we know that we have an alpha particle that is emitted, and this must be 4 and 2 for a helium particle. And so 214 plus 4 add up to 218, and 82 plus 2 add up to 84. And so there's our reaction. And now we're going to write down the masses for each one. So we have 218, 008973. We have 213.999805. And then we have the helium nuclei, which is 4.00260U. So in part B, we're asked to find the kinetic energy that's released in this reaction if we assume that the daughter nuclei does not take any of that kinetic energy, and so all of the kinetic energy is really to the alpha particle. Now, to find the kinetic energy, we're going to assume that the missing mass that is turned into kinetic energy. So let's calculate that. We're first going to start off by finding the mass defect, delta M, which is basically the mass that goes missing from the beginning to what you have at the end. So we have 218.008973 minus 213.999805 atomic mass units, and minus 4.00260U. And you'll get a mass defect of 0.006568 atomic mass units. Now, it's convenient to write that in megaelectron volts per c squared. So let's multiply this by 931.5 megaelectron volts per c squared. That's our conversion to megaelectron volts per c squared from the atomic mass unit that is given. And you'll get 6.118092 megaelectron volts per c squared. So now we're ready to find the energy that is released. That's that mass defect multiplied by c squared. So 6.118092 megaelectron volts per c squared, and multiply that by c squared, and you'll get 6.118092 megaelectron volts. And that energy is essentially the kinetic energy. And that's it for example number 5. You could extend it, by the way, and find, for example, the velocity using 1/2 mv squared. And now that you know this energy, I would then convert it into joules. You know the mass of the helium nuclei, which is given here. You may want to convert that to kilograms so that you can find how fast this particle is going. And that could even ask you things like, what's the momentum as well? Okay.